This conference will now be recorded.
Welcome everyone to Isha Training Solutions, and this is Roshan. So I'm here with my course, Cloud Performance Engineering in DevOps. So I'll be leading you through this course. So yesterday we had our first demo session, and today we'll be starting with our first topic, that's cloud computing. So if someone missed what all we will be covering in this uh, course journey, it's the list is here. I'm going to share the list with you. So if you can go to this link, find the I'm going to paste this link in the chat window. You can take it from there and save it somewhere. Okay. So that's the course, and I'll be mostly talking about AWS Cloud here. I'll be talking about Linux command line, microservices, Docker, Kubernetes. Uh, in Kubernetes specifically, I'll be covering EKS, that Elastic Kubernetes Service. That's the AWS offering of Kubernetes, then Jenkins, and then CI/CD pipeline. And we will learn a lot more about the other AWS services along the way. So if okay, so here my demo sessions are already uploaded from the last batch. So if you are interested, anyway, we are going over the demo session right now as well. So first, there are three demo sessions are already uploaded. So you can go over this and you can have an idea how we go about learning things. So the timing would be for participate in India, it would be 7 a.m. to 8 a.m. Uh, weekdays daily, okay, Monday to Friday. It will be IST time, Indian Standard Time, 7 a.m. to 8 a.m. And it will be for participants in US. It will be mostly 9:30 p.m. To 10:30 p.m. Mm. So and we'll be connecting daily at this time, Monday to Friday. For them, it would be Sunday to Thursday for you because we are ahead. In India, the timing is ahead. And in UK, it would be again 8th June, that was there. So we'll be connecting daily 2:30 a.m. to 3:30 a.m. for participant in UK. Okay, so coming back to the class course syllabus. Okay, so the idea here is to take it from very scratch, and that is where what the this course, the USP of this course, that we don't need any prior knowledge. You don't need to have any prior information to attend this course, because the course has been structured in a way that it is very much applicable to people who are very much new to this field also. So we'll be starting from very basics. So what is cloud computing? So I started with the first topic today. I will be starting. Just wanted to go over the course syllabus once again if anyone missed out yesterday. So cloud computing. So we'll be going over cloud computing introduction, the what is different service models, what is infrastructure as service, platform as a service, software as a service, different deployment models that we have. We'll be creating our own account and we'll be practicing hands-on. We will be doing. I have my AWS account with me, so I'll make you guys. Even you guys should have a AWS account. To get once you create the account, you can see something like this. The way I'll be showing you. Uh, okay, so just give me a minute. Okay, so you all will be having AWS account by end of only few sessions, two to three sessions. Everyone would have that, and we'll be going over all the services that we have. Mostly, not all very they have around 200 services. Very difficult to cover all, but we'll be covering the most basics, which is required, which is expected of you in nowadays in any interview. Okay, they would ask you these questions. So we'll be going over EC2 instance. We'll understand what is Lambda here. We'll understand what is S3 here. That's on the compute front. Then we have on the storage front, we'll understand what is S3, what is EFS, and there are on the databases front we have RDS. Okay, and we have a lot more services, okay, to cover. We have VPC, we'll be going over VPC, we'll be going over CloudFront. So there are a lot more services that will be going. So will be going over IAM, that's the security identity and access management service of AWS. So we'll be going over and we'll be doing hands-on. So, that is a part of the first first module here, and will be you can just read this here. Even if you're looking it like someone who can understand it's the new for them, that's fine, okay, because you guys have not gone through it. But we'll make sure that we are taking it from very scratch and then we are ramping up. We'll be talking about cloud monitoring, that AWS CloudWatch, that's architecture of AWS for the monitoring solution. Okay. What do we mean by private and public and elastic IP? We'll be talking about a lot about a cloud. So that's on the cloud front. Now coming back to Linux, because mostly we end up working in Linux operating system, whether are we working in microservices or containers or pods. Mostly we are working in our Linux operating system. You know that most of our applications are hosted in Linux operating system. And if someone asks me to go and check the server logs or the usage, what is the load average of my server, or what's the CPU utilization of my server, memory utilization, disk load average, what is the top consuming processes, how much memory is free, the how much CPU is being consumed by what process, what this process takes, how many threads are associated with that particular process. So there are a lot more things we need to know about Linux command line. My tagline here is get as comfortable with Linux operating system as you are with Windows. I'll make sure by end of this particular module, you'll be feeling comfortable. Uh, how to In Windows we can do stuff very easily. We can open a directory, we can read a directory, we can find a word in a particular file. If there are a lot of documents in one folder, I can find if I have that document or not. So a lot more things can be done. Okay, we can achieve that in same stuff in Linux as well. Whatever we could do in Windows. Only thing you need to know what command to issue and to get the information. So that's about the Linux command line module. We'll be going over that, and we'll be understanding the shell scripting as well at last for the performance monitoring. Let's say you do not have any commercial tools in your organization, but still you would like to capture CPU, memory, disk for the test duration. How would you do that? Uh, we know that there are commands like top, there are commands like mpstat, there are commands like free, there are commands like vmstat, there are commands like df, but those commands will give you the information, but how would you keep pushing the data to a file for the entire test duration? Let's say your test went for 1.5 hours or 2 hours. How would you do that? So we'll understand the shell scripting part of it as well. By end of Once you understand the basics commands, and then we'll be talking about the shell scripting as well in the Linux command module. So that's the second module that we have. Third module uh, talks about the container engine. Um, uh, the Mostly the software architecture first. We'll start with the architecture. We'll understand what is monolithic application and what is microservices and what's the advantages, disadvantages, and a lot more. And then we'll talk about where do we run these microservices, and a lot more. We'll be discussing a lot more, and we'll be practicing all these things in Linux. And that is why this Linux command line introduction is very important, because I have got this review, because uh, this course was designed after a thorough review process, and after batches, getting the feedback from people that they are new to Linux. How could they cope up with this subject? Because if I just start with the Linux operating system and I just start issuing command, there are people who 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 gives feedback that they are new to Linux, that they don't understand these commands. So that is the reason I've started with this, and then from the very basics, I'll introduce you with the Linux command line, and then only I'll talk about other Linux command that is required to work with Docker or the Docker Compose. We have Docker file, Docker volume. How do you create build image using Docker file, Docker volumes, Docker Compose? You can using Docker Compose you can create multiple containers at once. Your web server, your app server, your database server, all at once. You can use Docker Compose and you can do that. We'll see how to do that. Then we'll talk about container orchestration engine, Kubernetes. Okay, so when you have lot many containers, now you would like to orchestrate that. You need to load balance the traffic across your nodes, across your VMs. Then you have pod concepts. We'll understand how do we create pods. So we'll be all doing through YAML. Okay, here we'll be using YAML to understand that, and we'll be starting from very scratch. So did not worry. What is replica set? What is HPA? What is cluster auto scale? How do we configure auto scaling in Kubernetes cluster? Even in for the cloud computing, we are taking up this load balancer and auto scaling. Very important concept. How do you make sure for that your servers to auto scale if there are load coming in continuously, more load comes in? How would you make sure that your servers auto scales automatically with no manual intervention? How would you configure that? Because for a performance engineer, it's very important to make your system highly available, reliable. It is the most indispensable thing, how to load balance and auto scale. So that is on the server level. We'll also look into the pod level here in the case of Kubernetes. So in the pod contains your microservices. I'll talk about all those things. If anyone is new, if not able to understand the words, the terminology that I'm using, so need not worry. Okay, so we can do that. So we'll understand how performance engineering integrates with DevOps. Okay, DevOps will understand the CI/CD pipeline and how performance engineering fits in DevOps methodology. Right? We understood how this DevOps has come. Earlier, we had waterfall model uh, back in 1980s, 1990s. Waterfall model where software were developed all at once, and then we started to test. Then we had this agile model where with the complete software development process was divided into sprints, okay, different phases. And now we have this DevOps where everything is continuous, continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring. Everything is automated. We'll create pipeline and we'll understand how to achieve how to create CI/CD pipeline and how performance engineering fits in DevOps. And then we will look into the CI/CD pipeline, as I mentioned. How do you? We'll talk about Git. We'll talk about Docker Hub. We'll talk about how to create jobs. How to automate the email notifications. Uh, so scheduling pipelines. So a lot more. Okay. So that's about the course I wanted to touch base because yesterday I could not get time to go over this. So that's the course syllabus. This course takes around. See, it's a very vast course. I would say 5 courses. If you look at separately here, one is course for the cloud here, one course for the cloud, one for the Linux, one for the Docker and Kubernetes, one for the Docker, three here, four, and five, one for the Jenkins. So there are 5 courses in one course, I would say. 5 separate courses. I have combined all these things, and that is the reason it takes time because these are not just one course. It's a 5 courses in one. So it takes around time. We'll be going over 45 sessions. Uh, we'll be meeting up daily weekdays. Definitely, because last batch completed, it took around 47 sessions. So I'm guessing around it would take around 45 to 50 sessions for sure, and it would map to around 2 months to 2.5 months because it's 5 courses, not one course. That's the main thing here. And I deal in very from very scratch. That's what I we do take up things. Okay, so let's not devote any much time. If you have any questions here, I wanted to give you a time to ask questions so that you know what all we're going to cover and how we're going to cover. If you have any questions, feel free to talk to me. So we'll talk first, and then we'll start with our first topic here, which is cloud computing. Yeah. Feel free to ask any question. If you have any doubt, any concerns, if you're looking forward to join this course, even if you're not looking, if you want to rethink or whatever, if you have any doubts, any concerns about the course, let me know. Please ask.
Hey Roshan.
Yes.
So
Hi,
this
Ram.
Ram, this is regarding like what kind of profile once I got completed this course, like what is my profile? I'm a DevOps engineer
Currently,
or else I'm
okay.
a test
Currently,
engineer.
currently, currently, who are you? Like, what profile you have currently?
Currently I'm a performance engineer.
Performance engineer. So nowadays, you would be a performance engineer, still performance engineer. The point is, Ram, that all your companies is are expecting you to know this, because if you know, see, if you're a performance engineer, you must be dealing with architectures, right? You must be knowing architecture of your application. And what if the application is hosted in cloud? So it will be very difficult for you if you do not know the cloud terminologies. It's very difficult for you to understand the architecture of your application also. Uh, so if someone speaks about that, this is the public subnet, this is private subnet, this is this route table, this is this security group, and that load balancer, and this auto scaling group we have configured, and things like that. Kubernetes implementation. If someone has used Kubernetes in your implementation, how would you know? How would you go about testing it, the performance engineering it? So you need to know, as a your role would be a performance engineer, but you would also know about DevOps. So performance DevOps engineer, I would say. Your designation, your profile would say that performance DevOps engineer, because you have taken care of your cloud, you have taken care of your uh, microservices here, because you have gone through the Docker and the containers and the Kubernetes, and then the CI/CD pipeline as well. It's expected. It's the CI/CD pipeline is expected from you as a performance engineer. You would be asked to create a CI/CD pipeline. If not, work with the DevOps team in your organization to create CI/CD pipeline, or at least your job, performance testing job, so that they can integrate in the bigger CI/CD pipeline of your organization. So your profile will be same, performance engineer. You would be moved closely towards DevOps. So performance DevOps engineer, I would say, and it's very much required in any interview you go. You would be asked this question for sure. If anyone has gone through the interview, they they may also chime with me. I see one more question from Vikas. Are we going to get access to recorded videos for future sessions? For yes, you are going to get access. Yes, obviously. So these are the demo sessions. Everyone can get to see that. But once these demo sessions are over, Vikas, uh, the the access would be only to the restricted people. Not everyone would get to have the recorded videos, right? Only the people who are interested to join this course would be given access on daily basis. So you can, so as I'm recording the session right now, I'll be recording it on daily basis, and then you have the chance to go over, and you're expected to go over the recording session and practice, because I'll be demonstrating you, but if you do not practice, you will forget things. So that is how it is, Vikas. So Ram, is that I answered the question, I hope. Yeah.
Hi,
So
Yeah, thank you.
Sai here. I have a question on Jmeter. I never used Jmeter. So is it required that I'm prepared with some level of knowledge on Jmeter by the time we reach there?
nothing is required. Uh, Sai, right? Your name is Sai, right? Yes.
Yeah.
Right. So Sai, so what I'm doing here, it is not a JMeter course, Sai. Okay. What I'm doing here, I'm integrating Jenkins with Jmeter. I would tell you how do we run Jmeter script. I would just create a dummy script, and I would just show you how do we run the Jmeter script. First of all, the the focus here is to integrate your JMeter job with Jenkins so that it becomes a pipeline, okay, and it gets triggered automatically, because to push your code to production you need to have a performance check as well, whether your updated code is meeting the performance SLA or not. So for that you need to create a job, and the job would make sure that your performance is good as expected. Then only the updated code would be pushed to production. So I'll be not talking about Jmeter a lot here. I'll be talking about the integration of Jmeter with Jenkins. This is what I'll be talking here mostly.
Yeah. Okay. Thank you.
Sure.
Hi, this is Abu. I have a quick question here. So in terms of it's a performance engineering, so it's some sort of performance test plan, test strategy specifically we had to document during our test. So what is the difference? How do we document the test strategy? It will be different than the monolithic structure than in this kind of DevOps performance engineering. Like, what will be our what things do we need to be included in test strategy? So you mentioned about continuous performance testing, and also you mentioned about integration with the Jenkins. So these
Correct.
are the, so how these things comes into the picture?
See, the way you test, see why this DevOps has come, you need to understand that. So DevOps is there to make your deployment smooth or swift, I would say. So whenever the developer completes writing the code, now the problem with Agile is that it takes a lot more time to get your code to production. Okay, because everything is manual. So once the developer completes writing the code, it will check its build, its sanity, its compile time error, runtime error. Then he will provide the code to the testing team. Testing team would work in the environment build up first, and then they will build the environment with the updated code, and then they will start testing. The testing team could be QA, or where there could be automated scripts like Selenium scripts, and then there are PS performance team, as you are the part of, where you would be writing Jmeter scripts to test the applications, right? And then you go about testing it. So the point here with DevOps is that everything is automated, and that is why this DevOps culture is, because once the developer completes writing the code will be automatically built. There are jobs, multiple jobs scheduled, automated jobs. So the code will be built automatically. It will be pushed to the testing environment, and the testing environment would have jobs like for the QA automation. There would be a job who will do the regression testing. Then for the performance testing, you will have a Jmeter job, which would confirm whether the response time, the throughput, the SLA is meeting as per the expectation or not. Once your job is successful, only your code will be pushed to production, and that too will happen automatically. So that's about the CI/CD pipeline. Coming to your test approach, right? So again, it depends on the implementation. It again depends on the implementation, whether you have a monolithic or microservices. If you are using a monolithic, you're aware of the all those things. But if you have Kubernetes, so the way you test is differs. Like, either you have a UI to test or a REST API. In monolithic also you can have a REST API to test. Okay, so depends on the use case what you have. It is just the implementation. Kubernetes is an implementation, but the test cases would change here. Suppose if someone is using Kubernetes, so you know what to test. Let's say if you're using auto scaling, let's not talk about. I'll talk about Kubernetes later. But let's say you have just implemented load balancer and auto scaling group. Let's say in your architecture. So what would you test? You would scale up the server and you would test whether the servers are getting auto scaled or not, right? That's the one very important use case that you need to test. So whether this auto scaling is working or not, because if in performance environment, If auto scaling is not working, there is no guarantee that it will work in production. You need to test it. You need to also test that one server, one instance, one server can accommodate how many users. How many users can be accommodated in one server? So you need to find out, you need to benchmark that this server can accommodate this much, because as part of the auto scaling group, you would provision server. That server will have some capacity, and how many users can be served in that particular, with that capacity, that you need to test it out. So those are the use cases which comes up when you have auto scaling group and the load balancer configured. So that's about the server here. But coming to the pods implementation, let's say microservices implementation, if you happen to work, so again you need to test all these things. So the replica sets, so replica sets will maintain a stable set of replicas. So you would load test, you need to configure the horizontal pod autoscaler and the cluster autoscaler, and you need to test it out whether the pods are getting auto scaled or not as per the user requirement. And what is the criteria to scale the pod? So you need to, same thing goes there as well for the server. So if my CPU utilization goes above this much percentage, you need this much of instances provision. So you need to test this. So these are the additional test cases which should come into your performance test strategy document. If you have architecture like that, your complete testing would change, because you would test about the infrastructure, whether your infrastructure can support those additional load or not. So these are the additional use cases. I hope I answered your question. Yeah,
Yeah, pretty much. Yeah, thank you.
sure. Jakir has asked a question. Do we have any lab to practice? See, Jakir, everyone would be creating this AWS account. This is our lab environment. I'll be demonstrating you. So everyone would be on the same page. It's a free, okay? It's a free tier is available. We'll be mostly working on the free tier, except the Kubernetes EKS. That is chargeable, okay? So that is our lab environment. We'll be practicing everything here, Jakir. So are you covering integration of uh, performance center, LoadRunner, SAP? See, I cannot demo. Cannot just cover. If once you know, I can show you how to integrate. Okay, we have plugin in Jenkins. Once you know, Kavya, that you how to integrate your Jmeter with Jenkins, only any one performance testing tool, you can easily understand how to integrate your other performance testing tool like Performance Center or LoadRunner. There are plugins available. I will show you that, but I'll be demonstrating using Jmeter.
Roshan, I have one doubt. Actually, as you mentioned, you are doing that CI/CD pipeline through Jmeter, right? So now you answer that actually. Actually, we are using that Sovasta tool, that is Cloud Test Akamai. Now they changed. So if I learn how to do the CI/CD pipeline for this one using Jenkins, so whether the same can be implemented in any tool?
Correct. See, Jenkins is the most popular tool. Okay. Yes, obviously, right. Jenkins is the CI tool and it happens to be the most popular tool. If you're using any other continuous integration tool, right? That's what your question is, right, San?
Yeah,
That
actually, I'm using. We are using a cloud tool for performance testing. So we are not. Previously, we used the LoadRunner tool. Now we are using a tool called Cloud Test Akamai. So we can use the different data centers which is available around the world. So that is the reason we moved, because our application which is located in different data centers. So now I have an option to select what and all the data center which is available. So I want to do a continuous integration for that particular tool. So if I learn how to do through Jmeter, whether that will be helpful for me to implement the same logic over there in that tool I'm asking.
exactly. See. So your CI tool is the same, right? Jenkins only, right? Or it is
Yeah,
different?
I think we can use that.
Right. So if CI tool is same, it's very easy. Once you know, see, I'll be creating multiple jobs here. One job is for the GitHub. One job is for deploy your environment to the testing environment. One job is for the JMeter job. So if you know one how to configure your JMeter with Jenkins, you can easily configure other tool with Jenkins, because you have plugins, different plugins. I will demonstrate that for let's say for performance center, for LoadRunner, there is a separate plugin. For Dynatrace, You can also integrate your Dynatrace with Jenkins. There is a separate plugin for AppDynamics. You have different plugin to integrate with Jenkins, and that is why it is CI tool. It integrates everything. Continuous integration tool. That is why it is a CI tool. It integrates all other utilities, and that is why it is a CI tool. So we can easily learn that, sir. It's not a problem.
Okay.
I can also show you.
Yeah, Raj, thank you.
What is the question? Anil has asked me a question. Please help us to understand the optimization of Jmeter JVM for load testing. Jmeter JVM. Yeah, see, it is not a Jmeter course, Anil, but I can tell you that you need to configure the heap the JVM uses. Okay. You can see the utilization once you configure. I request everyone to go on mute, please. Yeah. So what you can do, there is a place where in the Jmeter application, if you do a right click, you can open that particular file in a notepad, and you can find that there is a place called the heap. You can configure the heap there, and then once you configure, you need to test that, and you need to keep on having a track using. You can use a tool like JVisual VM. You can have a track of its memory utilization, memory footprint, and then you can tune it. Okay, Anil. But it is not a JMeter course, but I have told you, and even if you need further details, I can also tell you. Yeah. Yeah. Any other questions, please?
Hey, Roshan, this is
Roshan, this
DVS.
is
Hello.
Yeah. Please go ahead. Yeah.
Yeah, in this part, I mean, part of this course I mean, how to monitor the infra level in AWS environment.
Correct.
This part of course
Correct.
will cover how to.
CloudWatch. Yes, CloudWatch. We have
Yeah, I
out
mean,
of the Yes, we have out of the box solution of in AWS monitoring that's called CloudWatch. So we'll be talking about CloudWatch. We'll be talking about how to monitor containers also using CloudWatch. That is called CloudWatch Container Insights. We'll be talking about a lot CloudWatch.
I mean, if you perform
Can
any sample load test, if you perform any sample load test and observe that infra, I mean,
Yeah, you can do
uh,
that, right? You have the servers, you can create the servers, you can load the servers. Once you know how to provision the server, you can load your application there, and you can just monitor it. We can
yeah.
do.
Yeah, and one more question. I mean, you already covered CI/CD. I mean, my question is, in the CI/CD for Jmeter integration, if you integrate the sample, I mean, sample report like that, client side and server side, like CPU and memory server side, and client side like any aggregate report like sample response times. Will I mean, once the load test is over, we'll integrate the sample report sent to the email or Slack. This
Correct.
is also will cover.
Email notification. Yes, you can send your entire thing, and you can configure the email notification. Yes, I have covered that. It must be noted somewhere. Automated feedbacks. So yes, you have email notifications. The email would tell you that whether the job has passed, failed. It will have your reports. Everything it will have. Yeah.
Report also will cover. That's what my question. Sample report.
Report Sample report means build log. Okay, build log. It attaches the build log whether the test passed or failed. It will have the build log attached. Yeah.
Okay, thank you.
Sure. Yeah. There was someone else who was asking question. I think Jakir. I'm not sure.
Zahid. This is Zahid. So I have questions about microservice
Sure.
deployment and profiling
Sure.
from the ecosystem. Will you map the microservice wherever that is hosted? In our case, probably AWS, and then
Yeah.
see the payload going back and forth. Will we measure that and all that?
See, for the monitoring, you have CloudWatch Container Insights. So once you have the cluster in AWS, okay, so you will have all the pods, all the services, you have all the components of Kubernetes. So you can monitor all this, your footprint of your pods, services, everything in CloudWatch Container Insights. You can monitor the infrastructure level, the pod utilization, your service utilization, your cluster utilization. You can monitor all these things using CloudWatch Container Insights. That's the out of the box solution of AWS. That's what we'll be covering.
Got it. Okay, thank you.
Sure. Okay. Is there any more questions? If not, I'll directly jump to our first topic, that's cloud computing. Okay, I take silence that we are good, all good, right? Okay, 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 sure. So thank you everyone for the questions. We'll start with our main topic here. We'll start with the first topic that we have cloud computing. Okay, so this will be the course topic that will be going in cloud computing. So we'll be starting with, as I mentioned, that introduction. So the course has already started today, okay, and we'll be having so we'll be spending our now 2 weeks of time from here learning about cloud. So if you are familiar with cloud, good. If you are not familiar with cloud, doesn't matter. You will be familiar. Only thing that I need from you to get up to the speed is to just follow my instructions, because if I ask you to create one account, you should have one. And if I go over whatever in the during the sessions, and I would like you to practice, that's all I need from you. And in this course, after having spent 2 weeks of time in cloud, you would be very much comfortable in cloud. That I can, you would only feel that. Okay, so fine. So we'll understand with the cloud computing introduction, why do we need cloud computing, and let's get started with the main topic. So that's the entire course syllabus I'll be taking up. So mostly today, whatever the time we have, 20 minutes left, 25 minutes left, we'll be going over the cloud computing introduction. Why do we need cloud computing? What is cloud computing, and the service models and the deployment models. So that's all I wanted to cover today, the first 5 topics. The other theoretical aspects we'll be covering today. Okay, so when I say cloud, what do we exactly mean? Okay, when I say cloud, what do we exactly mean? So when I say cloud, when I say data center, okay, so data center, it looks like this. So there is some infrastructure where you can find your hardware, all your resources, your cooling mechanism. So that this is your data center. I want you to imagine a data center. Your data center looks like this, and inside this building infrastructure, you have a, a lot more hardware that you can imagine, a lot of resources, compute resources, your disk, your memory, everything. So I want you to imagine this building here, and a lot more resources, a lot of hardware in the data center. That's what I mean by data center. Okay, so when I say cloud computing, what do I exactly mean? So the data center that you own, if you own this data center, let's say if you own this, own the land, the building, the hardware, it becomes an on-prem environment for you. There are confusion that people are struggling to understand what this on-prem and what this cloud is all about. It just depends on whether you own it or not. That is what the difference is, nothing else. There is no such difference. On-prem infrastructure and cloud, there is no such difference. If you own this data center, this land, this building, this infrastructure, all this server setup, if you own this, that becomes an on-prem environment for you. When you do not own this, when you don't own this, and you ask it, when you ask few servers to use, I want my deploy my application, can I use few of your servers? Let's say if AWS, Amazon Web Services owns this data center, you can ask few servers, can I use your few servers? So that becomes a cloud for you. As simple as that. There is no such big difference between on-prem and cloud. If you own an infrastructure, that is your on-prem. If you do not own it, and if you ask it for rent to use the servers, the resources to rent, to use it for rent, that becomes a cloud service for you. I was demonstrating that this is my AWS console, right? I would be also telling you how to get access it, but now this is my AWS console. what I can do, I can go to services tab here. There is something called EC2. I will type EC2 here. EC2 is Elastic Compute Cloud, full form. Elastic Compute Cloud. Using EC2, you can provision servers. You can ask AWS, you can use the servers from AWS. AWS has the data center. They have configured it. They have built it. They own the data center. For them, it's like on-prem. But for us, we don't own the data center, right? What we can do, we are simply going here and creating servers. So we are asking AWS for some servers, and I'll be paying them for some. Let's say I go and have 5 servers. I can create servers here. I can go to the instances. I'll demonstrate this later, and I can create servers here. I can create 5 to 10 servers, and then I'll be paying them some amount, right? That becomes a cloud service for me. But for them, for AWS, it is same. It is the same on-prem environment, but for me, it is cloud, right? So that's the difference I want you to know between an on-prem environment and cloud. If you own something, that is on-prem. If you do not own the setup, the data center, and if you want to, if you would like to just use the servers, and you can for rent, okay, you can just use it and you can pay the rent for that. That becomes a cloud service for you, as simple as that. So what is cloud computing? So what happened, like, see, so customers owning all the hardware. Let me start the major point. So the customers owning all the hardware and other components in the data centers. So before cloud, this was the case, right? They had to own, because before this cloud came into picture, if anyone wanted to deploy their application, they had to first set up the data center. They had to purchase the hardware. They had to do some cooling mechanism. They need to invest a lot in the security of the data center, a lot more cost. It was a very costly affair. Not everyone can afford to do that before cloud came into existence. But after cloud, even that is why you see a lot of startups nowadays, right? They don't need to set up the complete data center. They can simply go to AWS account, they can ask for a few servers, and they can host their application. They can load balance, they can use Kubernetes, they can have all the resources what even a big company would use. They have, even a smaller company can pay and use that. So that is what this, before cloud computing scenario, this was the case, that people did not had to own the complete hardware and other components in the data center to run the application or programs. But after this cloud computing allows people access to the same kinds of application through the internet. I don't have to go anywhere. I can just have my AWS account and I can create servers and I can work, I can deploy my application and I can have my security configured and I can just have my application up and running, my business up and running. And that is what the power of cloud computing. So why do we need cloud computing? The first important aspect, it is cost, it is efficiency, cost reduction, a lot more costly. It's very efficient on the cost, right? Scalability. If, let's say, I need more servers, my business is growing, I need more servers. I don't need to purchase more servers. I simply need to ask for more servers and I can pay them rent. As simple as that. And I will only pay for the time I use more servers. Let's say I need mostly 5 servers. 5 servers I need. But there are duration in my day where the user load is more. Let's say 10 to 12, 10 a.m. to 12 noon. During this time there is peak load and I need 10 servers only for during this time. So I can just provision. What was the case if I had to, if I have to set up the own data center, right? I have to purchase the complete 10 servers just for these 2 hours, 10 a.m. to 12 noon. I had to purchase the 10 servers. Then only I can configure and work my app and my application. But in the case of cloud, I can just ask for 5 additional servers. I have 5 servers already. I just had to ask for 5 additional servers for just 2 hours. So I'll be paying rent only for the 2 hours for additional 5 servers. And after 12 noon, they can take it back. I don't care because my user load is normal. So that is why this auto scaling is very important. I'll be paying only for the time I use the compute, the resource. I don't need to purchase everything. So that's the big difference. It's cost reduction a lot more. Okay, I cannot stress this point enough. So if you that is the region people are moving to cloud. You see so many startups coming to the cloud. Scalability, right? You can scale up. You don't need to worry about you need to purchase the hardware. What if you purchase if you're not using it? Oh, no need to worry. Just use it for the time you need, and then you can give it back. So they will only charging for 2 hours, as I gave the example here. Disaster recovery. You can have the setup in the case of disaster recovery. You can have one more your implementation, or you can push your data to a different data center, different region. I'll talk about region and all. So you can transfer your information from one place to another. So it can take care of your disaster recovery as well, being in cloud. Data security, your data is secure, right? So you have a lot of security mechanism. I'll be talking about it. We have IAM, we have security group, we have NACL. There are so many security aspects of it. So data is secure basically in cloud, much more secure, and without investing so much, right? That's very important. Uh, because AWS guys or Azure or GCP, they are the public cloud providers. They make sure that they're secure, and that is the reason people would go for them, right? If they are not secure, how people would trust them and uh, go for their cloud service provider? So that's their core business nowadays, right? GCP, Azure, and AWS. There are other cloud players as well, DigitalOcean, Oracle, IBM, Alibaba. There are so many cloud players in the market. They are providing servers for us to rent for rent, right? Mobility control and automatic software updates. You don't need to worry about the software updates. It will be done automatically. So we share a model. So customer cloud responsibility model. I'll talk about that. So if you look at the diagram here, so this was the setup, the on-prem setup, where I had to purchase everything here. Your data center, your networking, storage, servers, virtualization. I have to purchase the operating system also, right? If I have the servers, I need an operating system for those servers. I need a virtualization software. I need a networking mechanism. I need databases. There are so much costly affair thing was there when the cloud was not there. When I was setting my own data center, people were used to set up their own data center. They had to purchase the entire stack here. But now when the cloud is there, they can get all these things for rent, and they can just focus on their application. They can just focus on their application. That's very important point, right? Right. And virtualization, you know that virtualization, right? I'm just stressing in this diagram. I'm just stressing on the virtualization, that we have a bigger hardware here, infrastructure. I just need to install one hypervisor software or any virtualization software, and then I can create VMs. The way you create VMs in cloud also, it's virtualization. Virtualization is everywhere. Virtualization, right? So when I provision, let's say I know how to provision one instance. When I provision any instance, let's say launch instance, I can select free tier and I can select any operating system from the list. I don't need to have all those licensed with me. I get to decide whether I need a Red Hat operating system or Ubuntu or Microsoft Windows. Or what version. I get to decide what version I need. Let's say Red Hat I selected. Then I get to decide how many CPU and RAM memory I need for my server. I get to decide that. I can also select that and I can proceed. I get to decide my so instance detail. I can mention that how many instances I need. I'll talk about that, but I want to focus that I can provision instances, the servers, And I can do that because the virtualization is already been done from AWS front. And that is the reason I can create VMs. If virtualization would not have done, I cannot create VMs here. So they have done the virtualization, means they have installed the virtualization software or the hypervisor software. They have a big physical server. They have installed a hypervisor software, and then I'm just creating the VMs. I can create VMs of my need. I can have any operating system that I need, and I don't need to. I can just pay for the time that I use, and that is what the cloud computing is. I hope you guys have understood the difference between on-prem and cloud. There is not much difference. To sum it up, if I own the data center, if I own the everything here, I own it. That's on-prem infrastructure for me. If I do not own this, and if I just use any public cloud service provider to get everything, right, servers, your operating system, everything, that becomes a cloud service for me. So what is cloud computing? The definition of it. What is cloud computing? So I have been just talking about the on-prem and the cloud, but what is cloud computing? So cloud is using virtualization. Virtualization is being used, and the automation. That's the two word. That's the two keywords that you should take away from this slide: virtualization and automation. If you want to look at the automation at its peak, the best example of automation, look at any cloud service provider. They have automated like anything. You can create servers. The data center, I have so many regions. I, being sitting in Bangalore, I can create a server in Euro Frankfurt region. Being located remotely, I can create servers anywhere in the world, wherever they have regions. I can create in Europe, I can create in US, that too, North Virginia, Ohio, North California, or Oregon. I can go ahead and create servers anywhere in the world. So, this is the power of cloud computing. If my user base, why I need these many regions? If I'm building one application, if my user base happens to be in Australia, let's say that. So what I can do, or London, okay, let's say, or Australia, Sydney, whatever. I can create the servers there because the users, my customer, would get a better response time, better throughput there. Because servers are located close by, there will be less latency, right? That's the power. So depending on, or I can have multiple setup. I can have one server in Sydney and other similar setup in Ohio, because my user base is in both the countries. I can do that. So, and I can configure my servers based on my requirement. I get to decide what operating system it has to run. It should have. I get to decide how many CPU I need. I get to decide how many RAM I need, and a lot more stuff. I'm just giving you one example here. A lot more services are there. They have automated the entire stuff here. So, and everything is virtualized, right? So that's the best example here. So what is cloud computing? Just remember these two words: virtualization and automation. Using virtualization and automation to provide users with self-service. Self-service, it's a very important point. Self-service. I can get to decide computing products that provides infinite scale at low cost. And if you look at the characteristics, so cloud computing is a term used to describe the use of hardware and software delivered via the network, right? I If I just need an internet connectivity, I just need a computer, laptop, that's it, that's all I need. I can build my application. I can have any server I need. I can build my application, I can deploy I can have my business up and running. So I get to have the hardware and the software through the network. That's it. I get to provision that. I just need an internet connectivity. So simply put, cloud computing is computing based on the internet, right? I can. I just need to have an internet connectivity, and I can provision anything in the world, anywhere. I can create servers. So the few characteristics are on-demand self-service. Yes, it's a self-service. Rapid elasticity, yes, you can scale up automatically. So capabilities can be elastically provisioned and released. You can just go over this. So you can automatically scale, and both ways, scale up and scale down, both can be done. Okay, if you need more servers, it will be scaled up. If you do not need, it will be scaled down. Build on, I'll talk about this in the auto scaling group. How do we configure that? We need to talk about a lot more things about the CloudWatch alarm and on what criteria it should scale up, CPU, memory, how would you work on that? So a lot more things are there. Okay, we'll talk about that. Resource pooling. Obviously, you pool resources. You have a lot of resource options, and you can broad network access, yes, and measured service. You can also measure, monitor your server utilization and all those stuff. So these are what. So I would like you to understand this virtualization and automation. That's all about cloud. And I don't get to purchase it, okay, the hardware. I just using it for rent. That's what this cloud computing is all about. Okay. So now we can leverage this cloud service in, there are options we have, a lot of options we have. So this was the case here, the first, the leftmost diagram here, the one I'm circling. This is the on-premise infrastructure where I get to the blue here, I get to own, I have to own everything here, all the components here, the data center, networking, storage, servers, virtualize, everything I have to own it. But I can use the cloud service provider in three ways. I have three options. Either I can go infrastructure as a service, or I can go platform as a service, or I can use software as a service. It depends on what requirement I have. Let's say software as a service. You use Gmail, right? You use YouTube, you use Google Sheets, you use uh, the video calling feature, Google Meet. All these things are software as a service. You don't have control over the any underlying infrastructure, not even the application. You don't get to control everything. Who manages that for you? Cloud service provider. Let's say whatever example I gave, Google Sheets, Google Meet, Gmail, YouTube, Google is managing that for you. Okay. So that becomes a SaaS service. You are just using the software as a service. They are giving you as a service. So those are the SaaS services that you are using, because you don't have the control over anything. Everything is grayed out. You can see that everything is managed by the cloud service provider. In the platform as a service, what you do, you all this, the grayed out options is managed by the cloud service provider. Your data center, networking, till your operating system, databases, security, everything is managed by the cloud service provider. You just get to work on your application. You don't need to worry about the runtime environment. You can run your Java code, you can run your Python code, you can build your application. You can just focus on your application code. And in that case, you would ask for a platform as a service. You would use cloud as a platform as a service. You would ask that I need to use platform as a service. You please provide me all the necessary details. I don't want to install operating system. I don't want to install databases. I don't want to install even the runtime environment for my software development. I don't want to install I can use Java runtime. I can use Python runtime. I can use Node.js runtime, JavaScript runtime. I don't want to install any of this. Please provide me platform as a service. I want to use cloud as a platform as a service. So they would provide you all the necessary uh, resources, and you just get to control over the application. Then you can code your application. There are a lot of examples like online editors are there, right? Where you can write your Java code or Python code and you can execute it, right? So those are platform as a service. You are not installing runtime environment. You are not installing operating system. You don't get to install anything. You're simply writing the code, executing it, and whether it works or not, you're just checking all that. You're just working, focusing on your application front. That's the platform as a service. There is something called infrastructure as a service as well, where what happens? You get the control over the operating system, IaaS service we call it, infrastructure as a service. You get the control over the operating system. You get to decide as a customer. You get to decide what operating system you should have, what databases you want to use, what is the security mechanism, what's the security looks like. You get to configure that, and then you get to work on your application. The bigger companies, they do this because they get to decide the security and the database and the application. So you can ask, please provide me the data center. They have it because I don't want to own the data center until servers provide servers as well and provide virtualization as well. And then I get to decide my operating system. So the example what I'm showing here, when I was creating the instance, that is example of infrastructure as a service. They have given virtualization till this point. Now I get to decide the servers. I get to decide the operating system. I get to decide my databases here. What databases I should run, right? There are a lot of databases are there, options are there, RDS, DynamoDB. I get to decide that. They are just providing you a infrastructure. So that is infrastructure as a service, that is called. So that's the difference here between all these, the service models, we call it. So you can just read this: SaaS, affordable, anywhere accessibility, ready to use. Yes, you can use Gmail, YouTube, Google Sheets. You have so many options. So you can just see all those features that Google provides. You can just have a list here. All these things, whatever you see here, it's a software as a service example. Google is providing as a software as a service. You just get to use, you can simply click on photos and you can store photos, and you can use Google Docs, Google Sheets, Slides, Blog, Hangouts. You do, these are software as a service example. You have online editor, right? So those are platform as a service. You have online editor, so many online editors are there where you can write the code, whatever language you wish, and that is the platform as a service. And when you get to provision your servers, you get to select your operating system, that becomes your infrastructure service. Infrastructure as a service, minimize cost, yes, because you get to decide a lot. You have a much better control. Enhanced scalability, yeah, you can scale the application as per your requirement, and simple deployment. PaaS as a service, minimal development time, because you're just focusing on the development of your application. So obviously the development time is very less, and multiple programming language support. Obviously, they will have an enhanced collaborations. Yes, so that's the service models and benefits. Okay, I think we are top of our time. I don't want to breach. Okay, we'll continue from here tomorrow. Okay, and there are, so first of all, we'll be going over basics like this, and then we will talk about how we'll provision the, we'll get the access. We all should have the access of AWS account, and then we'll practice in coming few days. Okay, so let's continue from here from tomorrow. Okay, deployment model. Okay. So thank you everyone for joining. Let me know if you have any questions. Okay, I think I take the silence that we are good. Thank you everyone. We'll connect. Yeah, thank you.
Thank you.
Thank you.